I haven't heard anything.
No, nobody's nah.
I say let's just do it then, and
Yeah,
recording. Is that rude?
yeah, and then just have them watch it.
Yeah, they can get points that way, or I don't know.
Yeah, it's kind of hard when we change things last minute. I feel bad, and then
Yeah.
Yeah. Oh my gosh.
Okay.
I'm just pulling up the extension problems. I didn't think this was too bad. Did you guys?
Yeah, this one's all right. I mean, it's not anything. It's not too difficult. It's just kind of making sure you follow the rules.
Mm-hmm. I like these way better than graphs.
Yeah.
I hate graphs.
Graphs were bad.
And how to find stupid points. I don't get it. Anyway, I'm going to use these real fast. Okay. Do you guys have the extension problems pulled up, or do you want me to read it?
I have them pulled up as well.
I got them pulled up.
So this one, it ends up, you take x minus 3 equals 10 to the 4th because it's a log base 10.
Right.
So then it's x minus 3 equals 10,000. And then you're just solve for x.
Yeah, that's what I got.
And get x equals 10,003.
Yeah.
Okay, next one. So this is log base 2x times log base 2x plus 2 equals log base 2x plus 1.
So I started combining the first two on that side and did log 2x times x plus 2.
All for one log, correct?
Mm-hmm. So it's just you're dealing with the one log on each side.
Right. And then since they're both since the bases are the same, you can just set what's inside the parentheses equal to each other, right?
Yes.
You have x squared plus 2x equals 6x plus 1.
Yes.
Okay, and then you solve for x.
Yes.
So you get x squared minus 4x minus 1 equals 0.
And then you have to use the quadratic equation to find.
Okay, x squared minus 4 ac So it's negative of negative 4 plus or minus, or negative 4 squared minus 4 times 1 times negative 1, all over 2.
1.
Then so it turns into 4, so plus or minus 16 plus 4, all over 2, so you get 4 plus or minus square root of 20, all over 2. And then if you can break that down into 4 and 5, which gets you 2.
Sorry, hold on. My sister's calling. Hello? Hello?
So then that brings me down to 2 plus or minus 2 square root of 5. And then you can't have a negative number as it because of the domain, so it only becomes a positive. So it'd be 2 plus 2 square root of 5. And that, let me do that. So that comes to 2 square root of 5 plus 2 equals 2 plus 2 square root of 5. It gave me 6.47.
Sorry.
Let me see what I get.
So it's 2 plus.
Oh, it's not 2 square root of 5. I'm sorry, because the 2 canceled or simplified down.
So 4.23 or 24, I guess if you round up.
Wait, what did you get for the top?
So what it ends up being is 4 plus or minus 2 square root of 5 over 2. So then you cancel out the 2 from the bottom. So it drops down to 2 plus or minus the square root of 5. And then
But you can't have a negative because of the log rules. So then
Right.
it's 1.
Right, so you do the positive.
Wouldn't it cancel the first two, not the second?
It cancels the 4 and it cancels the 2 on top. Or no, it can't.
Or gosh, I'm looking.
It cancels out the 2.
Yeah, it reduces the 4 to the 2 and then 2 to the 1, but you don't write the 1.
So it's just 2 plus square root of 5.
Yes.
Okay.
And then if you put it in the calculator, it's 4.24, but I don't know how the answer key has it.
I haven't looked at the key.
It has it as 4.24.
Okay.
Okay, and then so the next one, so log of x minus log of x minus 1 equals 2.
And then that's the rule that if they're minus, they're really
Dividing.
right?
Yeah.
So it'd be log x divided by x minus 1 equals 2.
Yeah.
And then, well, I guess it would, I guess you would log the 2 as well, right?
I don't think you have to because you're just changing the form of that one side to a different form. And then from after that, then you do have to log. Yeah, you're right. You do have to log it because then it becomes x divided by x minus 1 equals 10 to the second. So yeah, you're right. Sorry.
Okay. No worries. X over x minus 1 equals 10 to the second.
Yeah.
X over x minus 1 equals 100. So if you multiply x minus 1 to both sides, you cancel that out from the denominator. Then you end up getting x equals 100, x minus 100.
Then you need to get the x back on the other side. So then minus 100x.
Then you get negative 99x equals negative 100. Divide by negative 99, divide by negative 99, so x equals 100 divided by 99. So you get 1.01.
Yes, that's what I got.
And
That's what I got.
Cool.
Awesome.
For this one, so 2 natural log x equals natural log of x plus 3 plus natural log of x minus 1. So for this one, so you would write it down as the same as the logs. So it'd be 2 natural log x is natural log of x plus 3 times x minus 1. And then you would just factor them and cancel out the natural logs. Correct?
Yeah, that's how.
Okay, so what it comes out to be is natural log of x squared minus 2x minus 3. Then you cancel out. So it's 2 equals x squared minus 2x minus 3. Is that the same for you, or?
I think I did something weird.
Oh, I'm sorry. It would be x squared plus 2x,
Yeah.
not minus.
Yeah.
And then you'd subtract the 2 from that one side, right? Or from both sides. So you get 0 equals x squared plus 2x minus 5.
Yes.
Is that right?
Yeah, that's. Hold on, I got. I got myself really confused here.
You what?
I said I just got myself really confused here.
Oh.
Sorry, I got lost. Can we start from the beginning again?
Yeah. So we wrote out the problem. And so what I did is if you're adding natural logs, it's the same as regular logs. So they're actually multiplying each other.
Oh yeah. Okay.
Then you factor those two out, or you bring them together. So it turns out to be natural log of x squared plus 2x minus 3 equals 2 natural log. And then since they're both the same base, or I guess they're both natural logs, you cancel out both the natural logs. So you're just 2 equals x squared plus 2x minus 3.
Okay. And then you'd have to use the quadratic, right?
I believe, yeah, you would have to. So x equals, so it's negative 2.
So you bring that 2 over to the other side, so it'd be negative 5, right?
Yes. X equals negative b plus or minus the square root of b squared minus 4ac negative 2.
So if I, even though it doesn't come out, if I put it in the calculator and do, I get just through a calculator, I got 1.45.
Yeah, that's what I got for 1. And then I guess it can't be negative either, right?
Yeah.
So this one says, so it says 1.5.
Well, I guess if it's 1.4, oh, that wouldn't work.
If it's 1.44, like if you rounded the 9, then it would.
Yeah. That'd be 1.5, just depending on how you round it.
Yeah. I mean,
I think that's how you do it though, right?
I would say we did it the right way.
I think, yeah. Antonio, what do you think about it?
I'm just trying to go back and find that because I can't remember a lot of the things you guys were saying. I remember how to do the last little bit, but I couldn't remember how to change the natural log back into the other way. So I'm just trying to find the rules.
Okay.
I get confused with them.
So if you have two of the logs adding each other, that what it really means is that they're multiplying each other. The insides are multiplying each other.
Yeah.
And if they're subtracting, then it means they're dividing.
Yeah. No, I mean I get that, but I just like with the first part, the 2ln natural log of x, I just can't remember how that goes. Is it x squared or is it x squared?
The 2 is just coefficient. So technically what it would be 2e to the x. But that's not what we're doing.
Oh. Yeah. Yeah, I was just
Yeah, after you multiply the other side together, that's why it's 2 equals, and then you factor it out, so it's the x squared plus 2x minus 3, and then you have to bring that 2 over to the other side so
Oh,
by itself
I see.
because it's the
Okay.
coefficient.
Yeah. Okay. I don't know what I was thinking.
I got myself confused, so good job, Mitchell, getting us all online.
No worries. Okay, so next one. So 1.02 to negative 4x minus 1 equals 5. So for this one, you'd have to change it into the log form. So the way that this works, from what I remember, is so you drop so the exponent becomes the leading coefficient. So it's negative 4x minus 1, and then it becomes log of the 1.02. And then in the parentheses is the 5.
Okay. Yeah, that's what I get.
Equals,
So then you bring the 1 over, and then you have negative 4x equals log base of 1.025 in parentheses plus 1. And then you divide by negative 4.
yes.
And then don't you have to do a base change here? And you change it, it's 1, and then it becomes like 1 plus natural log of 5 divided by natural log of 1.02. And then all of that divided by negative 4.
No, so you would just keep it the same. You don't have to do any log-based changes. Since all the parts in the log are filled in, you just use your calculator for it.
How do you do the base of a log?
The base of a log?
Yeah, so it's log base 1.02 times to the 5th.
So what you do is if you can't do it on a calculator where you input each part, you do log of 5 divided by log of 1.02.
Oh, okay. I think that's what I did. I just wrote it out differently. So you do log of 5 divided by log of 1.02 plus 1 divided by. Okay, yeah, that got me the same answer. Except for it should be negative, but since there's not negative, you just change it to a positive.
Which part?
Because you divide it by negative 4. So wouldn't that make this number negative? And since it can't be a negative, you just automatically change it to a positive?
Isn't it if it's negative, it's undefined? Or was that a different thing? Gosh, I'm having a hard time remembering.
Hold on one second. Let me see. Oh wait. Oh yeah, you can't subtract that. Whoops. Wait a second. I don't think I did this right. So I had the setup correct. So the exponent, whatever that is, drops in front as a leading coefficient, and then it becomes log of 1.02 of 5. That's what so that's how you change it into the log form from what that is.
Mm-hmm. I guess my question is, since when we're solving for x, since it's a negative 4, you have to divide by negative 4. So that would actually make your number negative.
Oh, yeah. No. Okay, that's what I did wrong. I'm sorry. It doesn't become the coefficient. So the exponent, you set it equal to that. So it's negative 4x minus 1 equals the log of 1.02 base 5.
Oh, that's what I thought you said. That's what I had.
That's what I wrote that down. I wrote it wrong.
Oh, okay.
Wait, you guys had 1.02 as a base?
Yeah. So that kind of changed places. So since that's the exponent, that becomes the new side of the equation. And then that coefficient becomes the base of the log on the other side.
So I don't know if this, I might be understanding you wrong, but so what I did was I changed the original one. I put log on both sides, and then I wrote it the negative 4x minus 1 log of 1.02 equals log of 5, and then I divided the log 1.02 over, and then I added 1 over, and then I divided all of that by negative 4. And I actually
It ends up
got
being,
the, huh?
well, you said it, you got the positive number?
No, it's negative still, but it's negative 20 point, well, if you round out 20.57.
Yeah, that's what I got too.
Yeah. So I think since it can't be a negative, that's what it.
And you just change it to a positive?
Yes.
Okay.
Huh.
I feel like you're just changing numbers.
Yeah. So we got the right. So we got that.
That was right. But I never look up the answers. Okay.
Yeah, it's 20.57.
Okay. Cool. Oh, fun. Money ones. So if 5,000 is invested in an account at 5.6 compounded quarterly, how much money is in the account after 10 years? And let's do that part first. Okay, so that equation is A equals P times 1 plus R over N raised to the N times T. So we're searching for A. So it'd be 5,000 times 1 plus 0.056 divided by 4 raised to 4 times 10, so 40. And then you can just plug that in your calculator.
You said 1 plus point
0.056
over
4,
over.
because it's 5.6%, and then you're compounding quarterly, so divided by 4. And then you raise that to how many times you're per year, so 4 times, and then the problem says we're looking for 10 years, so 4 times 10.
So 40?
Yeah.
Okay.
And I got $8,719.43.
Me too.
Let me see if I did this right. Sorry.
Oh, okay.
You said it's 0.056 divided by 4.
Mm-hmm. 0.056 divided by 4. And then that is raised to 40.
Times 5,000.
Yeah.
And what was your answer again?
$8,719.43.
Okay, that's what I got correct. Okay. Cool.
And then
And
the second part was how much money is in the account after 10 years if compounded and continuously. So that formula is A equals P times ERT. So 5,000 is our principal times E raised to 0.056 times 10. I got $8,753.36.
That's what I got.
you said 8. What was the number again? Sorry.
8,753.36.
Okay, yes, that's what I got as well. And those are both correct. Okay, so next one. So if you invested $400 into an account that invested an interest rate of 2% and compounds quarterly, how long would it take for the account to have $4,000? So this one would be, so it gives you the principal and everything. You have to solve for the time, correct?
Yeah. So it's that first equation we use.
So it becomes, so it'd be
4,000
equals 400 times 1 plus 0.02.
Yeah.
Over
4
raised to the
4t.
4t. Okay, so right off here, you would divide by 400, correct?
Yes.
Okay, divide by 400, so then you're left with 10.
Yes.
10 equals 10 equals 1 plus 0.02 over 4 raised to the 4t. And then would you subtract 1?
No, because you have to do 1 plus 0.02 divided by 4. You have to do that part first, because that whole thing is raised to the 4t.
Okay.
So I got 1.005.
Oh, so the 1 plus r over n is all in parentheses, correct?
Yes. Yeah, it's all together.
Okay, so the whole thing is raised to the nt power.
Yes.
Okay, that helps me so much. I kind of skipped over this part in the book, so it was just really irritating. I hate this stuff.
Well, see, I like this stuff better than the other stuff.
I mean, it's like fairly simple, but it's just like, for me still, I just like.
Well, it's annoying because it's like, I feel like it's irrelevant to what we need. There's stuff that figures all this out.
So I got 10 equals 1.005 to the 4t.
Yeah.
Okay.
And then this is the one where I always take that and I go 4t equals log of base 1.005 times 10. I don't know what rule that's called, but do a little switch through.
So this is literally the same thing we just did, right?
Uh-huh.
So it's 4t equals log of, what did you say again?
1.005.
And then 10 on the inside.
Yeah, on parentheses 10.
Okay, that's what I remember it as. So then you figure out the right side, correct?
Yeah. Then you divide by 4, but you don't divide the log. You have to do the base change again. I think we all did it a little bit different, but I do it as 1/4 times natural log 10 divided by natural log 0.005, and you have to put it in your calculator. And I got 115.42.
Yeah, that's what I got. Yeah, so the way that I do the log part, since I can't do it with my calculator, is I do log of 10 divided by log of 1.005.
So are log and natural logs the same thing?
No.
Because I did natural log and we get like the same answer.
You did natural log of what again?
So I did natural log of 10 divided by natural log of 0.005.
Sometimes they come to the same thing, but not always.
Because I thought in the example you had to do a base change.
Do you have it written down that I could see of how you do it, or?
Yeah. So like
Okay, let me see. Log of 4. Oh, okay. Yeah, I do it the other way. I don't remember how doing it that way.
But it got the same answer, so I mean, obviously it like.
Yeah, so I did the exact same thing you did, but I just used log instead of natural log.
But Antonio, you're saying it doesn't work all the time? I just want to make I don't know if I'm doing it right.
So if you start with one, you should finish with that one, because there's just certain problems, because I was doing that, because I have two different calculators, and my battery died on one, and when I was doing the homework, it was bad because that one didn't have the log, so I had to use the natural log, and I noticed that sometimes it was right and sometimes it was wrong.
So if it started with log and the problem, you're saying
I can't remember. I don't really know how to tell. I know that the natural log uses a base of E rather than the base of 10. That's what the log means.
Right.
So I don't really know what affects it.
Okay.
So I would say the best way to do it is to just stick with the log, because that's how I've been doing it, and that's how the book's been showing me in the homework.
Yeah.
Yeah, so I would just stick with just the log part,
Okay.
because that's how you. So like, because I can't insert the base or and all that in the calculator. So the way that you put it in the calculator is you do log of the x over the log of the base, and that
Okay.
means. So it's literally the same thing you're doing, but it's just log instead of natural log.
Okay. Cool. Thank you.
But yeah, that was the answer. It was 115.42.
Okay. All right.
All right, and then the next one. So assume the cost of a loaf of bread is $6. With continuous compounding, find the time it would take to cost for the cost to triple at an annual inflation rate of $5. So is this the continuously compound one?
Yeah, so it's the AP times ERT. So A would be 18 because you're just tripling $6, right?
Yeah. And then your principal would be 6 E, and then
Raised to the 0.05 T because we're trying to find T.
okay, so then you would divide by 6, correct?
Yes.
Simplify it, so then you get 3 equals E to the 0.5 T. So I think in this situation, the way that you would do it is if you took the natural log of each side. So what it comes down to be is the natural log of 3 equals the natural log of 0.05 T.
Yeah, that's what I got.
Okay. And then
Divide by 0.05 from natural log 3.
because the natural log would just cancel out the E, right?
Yeah.
Yeah, it would cancel out the E on this side, but then you still have 0.05 T, right?
Yeah, so natural log 3 equals 0.05 T.
Yeah.
Okay, I just want to make sure I was doing that right.
That's what I got.
About 0.05, and then you get approximately, so T equals 21.97.
That's what I got.
And that is what the answer comes out to.
Oh, good.
Sweet. Alrighty, so the next one. So Benjamin Franklin gives Boston a gift of about $4,400. This grew to about $2 million in 200 years. What was the interest rate compounded annually would this grow occur? So for this one, we're solving for R. So we're trying to find the rate.
Yes.
So what it would be is, so it would be 2 million equals 4,440 times 1 plus,
For R, because we're looking for R.
yeah, R over annually. So it'd be
1.
1. And then to the, what was it?
1 times 2, so 200. Because it's 200 years, so 1 times 200.
Okay. What was the N again? N is 1, right?
Is how many times per year you're compounding.
Okay.
Generally, it's just 1.
Times. Okay. Alrighty, and then you divide by 4,400, correct?
Yes, that's how.
2 million. So I get. So it gave me 454.54, or I guess 55.
Yeah, so 454.55 equals 1 plus r over 1 raised to the 200.
And then I guess would you take the 200 root of 454 times 55?
Yeah, because I think you would do so that it would be. Wow. I think it would be. Geez, hold on. I think so. I think on one side it would be 200 equals log, and then it would have to be the base of 1 plus r over 1, right?
I think I get what you're trying to do it in the log form. Is that correct?
Yeah. Should we not do it in that form? I don't know how to.
No, I think you can. So what it would be, so it would be log of. Hold on, let me see where I wrote this down. So it would be. Yeah, or I think you were right. It was 200 equals log of 1 plus RT over 1?
For the base, right? And then 454.55 in parentheses.
Correct. And how would you solve for R, though?
How do you get out of it?
So that's what. So let me see here, because I think I was trying to do it the other way. Let me try my way real quick, not to throw you off or anything like that.
No.
Okay, yeah. So my way actually worked.
Good. Tell us your way.
So I didn't do the log form.
Okay.
I literally just took the 200th power, or I square like the 200th root of 454.55. And so that gave me 1.03106 blah blah blah.
One
And then
point. You took the what did you do with the 454?
so I took the 200th root of it.
Okay, so that you do 200 and then the square root on the calculator, 454.55.
Yes. And then that gave me like 1.03. That's just what I'm going to round it to.
I did not get that answer.
So to do the 200th root, so what you have to do is you have to go to math. And then if you go down past the third root, there's an X root on it. Do you see that?
Well, yeah.
So what you'd have to do is you have to type in 200 first, and then go back to this math button and click that.
Okay. And then do 454. Okay, gotcha.
So that got me 1.03 equals 1 plus R over 1. And then I subtracted 1 from both sides, so I was left with 0.03. So I just, or 0.03106 equals R over 1. And then I just timed ones on both sides and
Got 1.03. Oh,
0.03106. And if you change that into a decimal, it's 3.1. And that's what the answer comes out to be.
okay.
Did that make sense?
Yeah, it did. Okay, I just need to remember to take the square root of 454.55. Okay, and that just
the 200th root, whatever that root is. Yeah.
Look, I found my sister had a calculator, a fancy one.
There you go.
Okay.
So.
Then Number 3.
This one says, as a team, discuss the different methods that you can use to solve the following equation. There are at least 4 different ways to solve this equation. No matter which method you use, you have to solve using a logarithmic function. Possible options are using a log base 3 on both sides, a log base 5 on both sides, log base 10, or a natural log on both sides. What benefits do you see for each of the following cases? The following guidance practice shows the log base 3 option and the natural log option. It doesn't matter which method you use. So,
You try log 3 first.
yeah.
So then it would be log 3, and then you would type in the parentheses 3 2x minus 1.
Log 3 base, yeah, and then it'd be 3 to the 2x minus 1, yeah, in the x equals log 3, or log base 3 of 5 to the x.
In parentheses. So how did it, does the 3 get canceled out in the first half? Because how would that be different? So okay, so then it would be 2x minus 1 equals 5x.
So it'd be 2x minus 1 equals the x log base 3 of 5. Since the base 3 and the 5 aren't the same, it can't cancel out.
Okay, so x log 3 5.
Yes. Since you understand why the other one can, right? Because the base and the x are the same.
Yes.
The 3's.
3's. Yeah.
Okay.
And the other one's not, but it has to be x log 3 5.
Yes.
Okay.
And then what you can do is you can do plus 1 on both sides. 2x equals x log 3 base 5 plus 1. And then you would divide the x. No, that wouldn't make any sense.
What do you divide by the 2?
Yes.
So x log 3 5 plus 1 divided by 2.
Yes. And then if you divide the x on both sides, you would just get 1.
So you don't want x. I guess you have to get x to the other side if you do that.
Yeah.
But it's times, so
So I don't think you can solve it using this way. Because if you put x's on both sides, it'll end up being 1.
okay. So try the log 5.
Well, yeah, so we try the log base 5 this time. So then what that would come down to, so it would be 2x minus 1 log base 5 of 3 equals x. Are you following me, or are you lost?
Yeah, I follow how you put it, but I don't know how to like solve it.
Yeah. So you got the 2x minus 1 log 5/3 equals x, right?
Yeah. So since there's time, would you divide the 2x minus 1 over to the other side?
Yeah, that's what I would do. You get log 5/3 equals x over 2x minus 1. But then you'd have to...
No, it won't work. You have to take the log again, right?
Yeah. Yeah, so that wouldn't work either.
So, or try the natural log. How would you?
The natural log for each side. So the bases would be what would be x, and then the exponents drop as coefficients in the beginning too. So it would be, so if you did, so it'd be the natural, so it'd be 2x minus 1 natural log of 3 equals x natural log of 5.
Mm-hmm. Remember back to that format that I got confused about last time.
And then for this one, you would factor the natural log of 3 to the negative 1 and the 2x. Does that make sense?
Yes, because it's time. So then
2x natural log of 3 minus natural log of 3 equals x natural log of 5.
yes.
And then what you would do...
Do you factor out the natural log, or is that possible?
No, you wouldn't factor that out.
Okay.
So what you would do, so if you need to get x on both sides, so you would add, so I would add the natural log of 3 to the other side and subtract the x natural log of 5 to this. So like switch them. Does that make sense?
Mm-hmm.
So then what you get is 2x natural log of 3 minus x natural log of 5 equals natural log of 3. And then what you do is you pull that x out of both of them.
Oh, okay. So then you get 2 natural log 3 minus natural log 5 equals natural log 3.
And then you divide the whole left side, not the x, by the natural log 3. So then x ends up equaling natural log of 3 all over 2 natural log 3 minus natural log 5.
And you can plug that in the calculator.
Natural log of 3 divided by 2 natural log of 3 minus natural log 5. So then you end up, for this one, you get x equals 1.869 or 1.87.
Okay.
You get that one. So now for the other one.
Wait, there's another one?
Well, it said you can do, she said you can try the log base 10 on both sides, but I don't think you can't do that, right?
I don't think so.
Because the 3 and the 5, they have to be 10. Right?
Yeah.
Yeah, so you couldn't do the 10.
I feel good about that side.
That's just what I would do. Right, I guess that's what I'm saying, is you can't.
Yeah, they're saying there's different options, and it doesn't matter which method you use to solve it. So I guess we could just see if we got the answer. And that's...
Yeah, so the natural log of everything that worked.
Okay. Cool. Kind of a...
And then these half-life problems. Did you grab the equation for what half-life was?
I think it's...
Or how to calculate the half-life?
I think it's A equals A 0 sub 0 ERT. Oh, okay, hold on. Yeah. I think that's the drug elimination one. Yeah, A equals A 0 ERT. So A is the amount that it's going to be, and then the A to 0 is the initial amount present, and then R, annual rate of decay, and then time.
How did you have it written? Sorry.
Oh, I just had it in my notes.
Okay, so you had, so initial times E to the RT.
Yeah.
R was rate, and then T is time, correct?
Yes.
Okay. Cool. All right, so then this one says, the half-life of carbon-14 is 5,730 years. How long does it take for 3.4 grams of carbon-14 to be reduced to 0.1 grams of carbon-14 by radioactivity?
So our initial, or what we end up is 0.1. So when you set at 0.1 equals the initial amount, which was 3.4
times E.
And then we're trying to find the rate, right? No, we know.
We need to find the rate, correct?
But it says how long does it take? But I think we have to find the rate before we can find the time.
Yeah.
So we know the time, right? Is that the
5,730?
That's what I would assume.
Okay. So 0.1 equals 3.4 E, and then time, so R, and then time would be 500 and 730.
So you divide by 3.4 first. So 0.1 divided by 3.4 equals 0.0294 equals E to the R times 5730, correct?
Yeah.
And then what you do is you take the natural log of both sides so that the E cancels out, correct?
Yes.
Okay, so natural log of 0.09 equals R times 5730. The natural log of 0.0294 is a negative number.
So would you do natural log of 0.0294 divided by 507.30?
Yes, but that gave me a negative number.
I swear this is we had to do this as a two-step problem, right?
Yeah, you gotta find the rate first, and then you plug it back in to find the time of what they want. Because first you're trying to figure out the actual rate, and then you're trying to find the rate to the 0.1 in this case.
So that you do 0.3 equals 3.4 E, and then raised to that number we just found times T. Is that what you're saying?
So, so when you get what the rate is, so I got that the rate is, let me finish it here. So I got that the rate is negative ln 2 divided by 5730.
Yeah.
That's what I got for the rate. And that then once you have that, you have to plug in everything in again. How you started, the A equals A0 E RT, but instead of putting, so then the R, where the E to the RT, the R would be what you got there. So the first number E would be the let me see, the 0.1 equals 3.2 or sorry 3.4 E to the negative ln 2 over 5730 times T. So let me write it out.
So
I'm looking at my notes, so let me.
When I was looking up the equation of half-life, it was different than what you had said, Monique. The E is 1/2. There's no E in there. So the initial time half of the time over the half-life.
Oh. Sorry.
So maybe it's just maybe it's you're referring to the other one, maybe the continuously compound one. Well, this is what I found looking up what the half-life equation was.
Will you write it or show me, and I'll write it down and then.
Yeah, so it's A equals A initial, so A to the 0 subscript, times 1/2 to the T over H, and H is the half-life.
So, like that?
Yes.
Okay. So, yeah, I had that completely wrong then.
So T is time, and H is half-life.
So that makes more sense because it tells us the half-life.
Yes.
So then it would still be, so 0.1 equals 3.4 times 1/2 raised to, we're looking for, so time times 5730.
Yes.
Okay.
So then you'd still do the divide by 3.4 from both sides. So that comes out to 0.0294 equals 1/2 of T to the T over 5730. And then this, what you would do is you would just do the log, since it's in that format. Remember that?
Okay.
So so what it comes down to is, so it's T over 5730 equals so log of 1/2
of 0.294.
Yes. Then you just have to solve that log part over there first.
Is that where you did the log, like log 1/2 divided by log 0.294?
So flip them. So you do the log of what x is over the log of the subscript.
Okay. So log 294 divided by log of 1/2.
Yes. So what I got is 5.088 and so on. And you multiply that by 5,730 from the other side. So you get T by itself. So then your T ends up being 29,154.47 years.
2000. What was it? 2000.
2009 to 29 or sorry 29,154.4694. And the answer is off by 3 years.
So what I did, I got the right answer, guys. What I did use Monique's the A equals A0 E RT, that formula. You use that first, and then when I got, I'll show you guys here when so I got, gosh, I don't know if I don't know where I started here. Let me see. So right here I started it, and then I plugged it all in, and then you work all that out, and when you get, I didn't really make clear what I got out of there, but it's somewhere around here. Once you get that, you plug it into the R in the original equation, but you change the A to what they want to know. And in this case, they want to know the 0.1. So you have 0.1 equals the 3.4 E to the new rate T. And so you solve for all of that. And then you work all that out, and then you should have that. And then you work all that out, and you should have what it says. I don't know if that makes sense. I know that in the homework, if you want to look at the homework, it's on the second part of the homework on my math lab, and there is I don't know which problem it is, but there is a problem about the half-life, just like this one.
Okay.
And I took notes off of it. That's why I remembered.
So I did it again, Monique. And so I think what the problem was is that I cut off the 0.0294. I cut it off right there, so it kind of skewed it a little bit. So I plugged in the rest of the numbers from what I got.
So just both ways works, doing it that way.
Yeah. So I just rounded when I shouldn't have. So if you don't round and you continue the process, then you get the right answer. So I just got the right answer.
Okay.
Have you guys done the second part of the homework yet?
I haven't.
Don't round up. Don't round up. Because if you round up, it's going to do the same thing you just did.
Yeah. Okay. So
actually, if you round up, if you read the problem before you do it, it'll tell you if you round up. No, never mind. That's at the end. Never mind. Don't listen to me.
Okay. No worries.
I'm confusing myself too.
I think it will make more sense when I do homework too.
Yeah, so don't round that, Monique, in the process that we just did it until the end.
Okay.
All right, so the next one. 15 grams of radioactive waste reduced to 10 grams of radioactive waste after 1,000 years. And what is the half-life for this radioactive element? This one we're finding the half-life. So what it ends up being, so 10 equals 15 times 1/2 of 100 over H.
1,000, right?
What was that, Monique?
Isn't it 1,000 years?
Oh, 1,000. I'm sorry. You're right. Alrighty, and then we do the same thing here. So we do 10. So we can divide by 15 by both sides to bring it down. So what ends up being is 0.666. How many sixes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 nines. Or 9 sixes, sorry. Goodness gracious. And then this is just the same exact thing we just did. Are you following, Monique, or?
Yeah. Will you say it out loud though? Just
Yeah. Okay. So what I did, so I divided 15 by both sides.
And got the 0.96s and 7 equals
Yeah.
1 raised to 1,000 times x.
Yes, and then we're going to do the same log thing here. So what it's going to transform to is 1,000 over h equals log of 1/2 of that 0.6667, like all the way down there.
Yeah.
And then, so you're going to solve that log first.
And that's log of x.
Log of x over log of the b, so the subscript.
I got 0.5849625007.
What was that? I'm sorry.
Did you get 0.5849625007?
I got 0.6. We can see if we get the same answer.
Okay.
And then so if it's 100 or if it's 1,000, you divide by 1,000, right? Since it's in the numerator.
Why don't you times it by 1 over 1,000?
Yeah, so you'd end up dividing by
Yeah.
1,000.
I don't think I got the right answer.
Yeah, that one wasn't right for me either. Maybe it's different on this one. But it shouldn't be, should it? If 15 grams of radioactive waste reduces to 10 grams. So you start with 15 and it comes down to 10 after 1,000 years. Then what is the half-life for this radioactive element?
Antonio, how are you approaching it? Are you using
What? Oh, hey, what?
This was in the textbook, right?
I don't remember seeing this one.
I'm gonna try to look it up real quick because I feel like it would just work the same way, right?
Yeah. Okay.
Chapter 4. Okay, yeah, we should have stuck to your way, Monique. 'Cause that's what the book is saying. I'm sorry. Is it you had the right equation? It was A initial times e to the RT. So yeah, I'm sorry. Don't listen to my equation. So then so then we can do it. So then I'm sure we can do it correct this time. So it's 10 equals 15e. And then what did R represent? R is rate.
So I think we have to find the rate first and then plug that back in.
And then T is time, correct?
Yeah.
Okay, yeah, you're right. So it's R times 1,000. So then you do, so this would be that 0.666 equals e to the r of 1,000 times 1,000. And then you do the natural log of both sides. Does that make sense?
Mm-hmm.
I guess the easier way you can do it is if you just do the natural log of 10 divided by 15 instead of typing in all those numbers.
So, sorry, you said natural log of 10 divided by what?
15. Because if we didn't simplify 10 over 15, does that make sense?
Mm-hmm. Oh, I see. Yeah.
So then that gives us that negative number, negative 0.4054651,081, and then you have to divide that by.
Oh, natural log of 10 to 15, I got 0.1535.
For the natural log of 10 divided by 15? I got a negative number when I plug it in my calculator. Did you get a positive?
Uh-huh. I'll type it in.
Huh. Why is that different then? Oh. Let me see if I can find an example on here for us, just to help us out a little bit. So we were solving for R, right?
No, we found R on the first one, so I think we're solving for T now.
Okay. See, shoot. See what you get, Monique, if you do that, then you divide it by about, nope, that's so easy. Or does it? No.
I'm not doing it right. I'm not getting a negative number. Does it have to be 2 steps, or is there an easier way that we're just not thinking of?
That's what I'm trying to see here. I'm trying to see. The first way, the equation that I found worked for us, and it worked for me. But now it's just not coming out for the second one.
Yeah.
Or maybe we are doing it right. Because you're saying, because what I'm looking at here is they do the exact same thing, and they get a negative rate, and then they plug it back into.
And plug it back in, and then it comes out positive, right? So for the rate, it was natural log 10 divided by 1,000.
Natural log. Where did you get the natural log 10?
That's a lie. It's not true. I forgot to do the divided by 15 first. So be
I'm gonna check this real quick. I'm sorry.
So I got one. So I did natural log 10 divided by 15, and then divided that by 1,000, and I got a rate of 1.5352 times 10 to the negative 4.
See, I'm getting negative numbers.
Well, I think that is negative because it's to the negative 4.
I got negative. I got negative 4.05 times 10 to the negative 4th power.
Oh.
So now, if I plug that back in, T. So that would mean that becomes over there. No, it doesn't make sense. Or maybe, no. Oh, goodness gracious. This is literally bugging me.
Well, that part didn't work either for me. I'm doing something wrong. I've tried it 4 times now, and I can't get the right answer. Doesn't make any sense.
Wow, sorry, natural log. Oh my goodness. Why is this so Antonio, any idea? Are you getting close or?
I just got it. So, it took me a while because I wanted to make sure. I tried it 3 different ways. So, it's just like before. So you start with, you're actually solving for time first, and then you plug that into the original equation. So you want to put let me see how I did it. So I put 10x equals 15e to the 1000 times t power, and then you divide the 15 over. So it is 10 15ths equals e to 1000 t power. So then you do the natural log on both sides. So
Okay.
it would be natural log 10 over 15 equals 1000 t. Then you divide the 1000 over, so that's t. So once you have that, you actually put 7.5, because that's the half of 15. 7.5 equals 15e to the r times what you got for t. Am I going too fast, or?
So can you back up to where you got? So you solve for t. So t equaled the natural log of 10 over 15 divided by 1,000.
Yes.
Okay, and then what was
Yes.
your step?
So now that you have t, you plug it back in. So it would be 7.5 And I got 7.5 because it's the half of 15, and we're trying to find the half-life. So 7.5 would equal 15e to the r times and whatever you got for t.
Oh, so
And so what?
things simplify that.
No, you don't want to simplify that.
Oh, okay.
And so
natural
and
log.
so yeah, you have to write all of that out.
Okay.
I mean, I guess if you want to try to do that, but you'd have to actually write out the whole thing, I think.
Yeah, no, I understand.
Okay.
But once you have that, you just divide the 15 over, and you actually write it as 1/2. So it'll be 1/2 equals e to the, and then whatever you had at the top. And then you actually split up the 1/2 with the ln, or sorry, the natural log. So with the natural log on both sides, you cancel out the e. So it would be, and then because you want to split up the 1/2, it would be the natural log of 1 minus the natural log of 2. And since the natural log of 1 is 0, it just cancels itself out. So you're left with negative natural log of 2 equals r times and that. And so you would divide the negative natural log of 2 by what you had for time, and that will give you the rate, and that will be the answer.
So I didn't separate the 1/2, and I still got the same answer.
Yeah, well, yeah. If you leave the natural log, then you don't have to. Yeah.
Yeah, as I said, I just did I kept natural log, and then divided it by the rate, and then I got.
Yeah. Yeah. As long I just did more steps. I don't know if that made.
Yeah, that made sense. Thank you.
Sense.
That makes sense. I'm just trying to.
I think where I was going wrong is I didn't. I was trying to keep the 10 in instead of doing the half-life, the 7.5.
Yeah.
Because I was doing those same steps. I just didn't do. I didn't replace that new half-life in there.
Yeah. I had to really read it. I kept reading it over and over again because I was thinking they're not giving you what they normally give you. So I thought, oh, you probably got to solve for something else then first.
So I did. So I understand everything. So when you go and plug it back in, you have to make sure you put it at half of what it originally was, right?
Yes.
Okay.
Yes,
so
that's how you get the half-life.
Okay, so.
And I think that's where we were going wrong, is we were trying to put the same thing back into the original equation, and it wasn't working.
Yeah. Okay, I get that.
But you have to figure out either rate or time first, and then you can do the half.
And then plug that back in. With the half.
Okay, that makes completely more sense now.
Yeah, thank you, Antonio.
Whew, that was a
It
mouthful.
took me a long time to figure it out.
Those are crazy.
Yeah, and we have another test this week. Why? We have so many tests.
I don't even know. But it says it's 5B, so I feel like it's continuing from what we were doing. I feel like it wouldn't have any of this stuff.
Yeah.
So.
Cool. So I'll submit the link in tonight. Is that okay?
Yeah.
Yeah.
What should I do for participation points for everyone? Since we did change it.
Yeah, that's what I don't. I mean,
I know that wasn't it said that we could split up the group if it needed to be?
Yeah. Also, maybe I'll just say this part of the group could meet tonight, and then I'll just say that our group, us three could meet tonight, and then because didn't someone say in the Google chat that they were going to split the meeting?
I think
that's what I thought, but I don't know.
So maybe I'll just say, hey, if you guys do a meeting, make sure to submit your link in for the meeting that you guys could do.
Yeah, you should just have them say, hey, meet together, see if you guys talk it over, and then submit the link.
On there, and I'll submit it for us three.
Yeah.
Okay. I think that's good, right? As long as they know.
Yeah. And then we have another group meeting too, right?
Yeah, tomorrow.
Okay.
For the
Do we have a group quiz this week?
mm-hmm.
Oh, gosh.
So that'll be fun.
Yeah, so it looks like for the group meeting tomorrow, it looks like there is graphing for one part. There's graphing for one part, and then the other one is solving like we were.
Does it look pretty intense, or do you think we'll get it done fast?
It looks pretty simple. The first, like some of them look like from earlier this week, so like the easier stuff.
Uh-huh.
There's another part that talks about compound interest and stuff like that in Half-Life.
Which we did.
Okay.
So.
So we should be able to get it done. There, yeah, we should be good.
Okay. All right, so I'll submit it in tonight, and then I'll see you guys tomorrow.
Okay, so 8 o'clock tomorrow again.
Yeah.
Wait, sounds
See ya.
good. Good stuff, guys.
Thanks, guys. You're awesome.
Yeah.
Bye.